Hi, I am Kiranmai. Welcome to my channel Chemistry Tutorials by Kiranmai. In this video, I am teaching about photoelectric effect. This photoelectric effect is one of the phenomenon which is not explained by considering only wave nature of electromagnetic radiation. So let's go into the topic photoelectric effect. In 1887, scientist H. Hertz conducted a very important or very interesting experiment. In this experiment, he took a metal and then incidented or exposed this metal to electromagnetic radiation, and then he observed that the electrons from the surface are ejected. This phenomenon is known as photoelectric effect. It is also referred to as photoemission. Photoemission. And the electrons ejected from the metal surface are called photoelectrons. Photoelectrons. We are naming it as photoelectrons, but these are similar to the electrons in their properties and behavior. Just the prefix photo is added to indicate that these electrons are ejected from the metal surface by the incident of light. So light means photons. So here the light, through light these electrons, by the effect of light, these electrons are ejected. So we are giving it the prefix photo. So these are the photoelectrons ejected from the metal surface. See, the experimental apparatus will be as follows. These are the apparatus. In this, we are taking a vacuum chamber, and to it we are connecting detector to the positive terminal of the battery. It is also connected with the ammeter, which detects the current, and a metal is connected to the negative terminal of the battery, which acts as a negative electrode. So here, when the light is made to incident on the metal surface, this is light, strikes the metal surface, then what is emitted from the metal surface? Electrons. So negatively charged electrons are ejected. So this negatively charged electrons obviously move towards positively charged one, detector. So these electrons strikes the detector, which is connected to ammeter. This ammeter measures the current. Flow of electrons are nothing but electricity current. So the electrons ejected reaches the detector, and then the current produced, that is the amount of electrons produced, can be measured using ammeter. These are the equipment. So here, after conducting an experiment, the following results are noticed. First one, the electrons ejected from the metal surface as soon as the beam of light strikes the surface, that is, when the light strikes the metal surface without delay in time, electrons are ejected from the surface, just like reflection of light. When light incident on metal surface, then the electrons are ejected from the metal surface. There is no time lag between the striking of light and ejection of electrons. Second one is the number of electrons. Here the number of electrons depends upon, that is, intensity of brightness of light. Here, if the intensity of light is more, the number of electrons ejected is more. If the intensity of light is less, then the number of electrons ejected will be less. So number of electrons ejected is proportional to intensity of light. Here the intensity means, if we consider the light as a wave, intensity means the amplitude, maximum displacement from the central point. If this one is considered as wave, the displacement of wave from its central point is considered as its amplitude. So shorter the amplitude, less electrons are ejected. If it is the greater the amplitude, then more electrons are ejected. So number of electrons is proportional to intensity of light. This is also known as brightness of light or light amplitude. Next, third one, each metal has certain minimum frequency. It is also known as threshold frequency. Let's it be mu naught, below which photoelectric effect is not observed. Below this, photoelectric effect is not observed. And then this photoelectric effect has to be observed, then the frequency must be greater than threshold frequency. Then only the photoelectric effect is observed. And kinetic energy of these electrons, so electrons are on the metal surface. When it gets into the motion, then the static energy will be converted into kinetic energy. So kinetic energy of these electrons increases with increase of frequency of light. Here we said intensity. Now we are saying that frequency. See, kinetic energy of electrons is proportional to intensity of light. What is meant by intensity means at a particular point of time. Let's say in 1 second. Here is at a certain point. Let us consider this one as a point. And in 1 second, how many waves travel through this point is considered as intensity. So kinetic energy of electrons are proportional to intensity of light. These are the results observed during this experiment. So after conducting this experiment, scientists, based on the classical physics, up to that they are in the thought that electromagnetic radiations are in the form of wave nature. So considering this wave nature of electromagnetic radiations, scientists made some predictions. First one, kinetic energy of emitted electrons should increase with light amplitude. Kinetic energy of emitted photoelectrons should increase with the light amplitude. Let's consider one example. Let's assume the light waves is similar to water waves. And then metal surface, let's assume some dock. Metal surface as the dock or bench extended in the ocean, and the balls present on this dock be the electrons. Let's assume like this. In ocean, the dock is extended and on the dock the balls are there. Let's assume this one as electromagnetic radiations or light, this one as metal surface, and the balls present here as electrons. And here light amplitude means here the wave. If high amplitude wave hits the dock, then the balls gets displaced with high speed. That is, the kinetic energy of these balls will be more. If we consider this as high amplitude, then the kinetic energy will be more. So here amplitude means displacement, considered as water wave. And then the electrons displaced from the metal surface are similar to balls. If the big wave hits the dock, then the balls displaces with high speed. If a shorter wave hits the dock, then the balls displaced with the less speed. Similarly, when the electromagnetic radiations with high amplitude hits the metal surface, then the ejected electrons will move with the high speed. If the electromagnetic radiations with the less amplitude hits the metal surface, then the ejected electrons will have the less kinetic energy. This is the first prediction. And the second prediction is the rate of electron emission is proportional to measured electric current should also increase as the light frequency is increased. Simply, light frequency is proportional to rate of emission of electron, or rate of emission of electrons should increase with light frequency. So let's consider with the same example. I will explain this. If the dock is hit by same amplitude waves, we are considering two situations with the same amplitude, means same wave. The displacement of wave will be same, but the number of waves hitting the dock we are considering. So frequency means number of waves passing through a certain point in 1 second is known as frequency. So here the amplitude is same, but the number of waves hitting the dock is different. In first case, if the more number of waves hit the dock, more waves hit the dock, then more balls get displaced. So if the number of waves hitting the rock increases, then the balls getting displaced will also be increased. More displacement. If you consider one or two waves are hitting the rock, means less waves, then the balls displaced will be less. Similarly, when the more frequency light hits the metal surface, then the electrons ejected will be more. The rate of emission will be more. If the less frequency light hits the metal surface, then the rate of emission of electrons will be less. So these are the assumptions of scientists. These are only assumptions of scientists based considering only the wave nature of electromagnetic radiation. And let's observe deeply the results. When experiment is conducted, the results are quite different. So the following results are observed. Let's see, like observations. First one, here we said kinetic energy of emitted photons should increase with light amplitude. But when we observed, the assumption is completely wrong. Here, kinetic energy of emitted photons remains same with the increase in light amplitude, but it increases with light frequency. See, kinetic energy of photoelectrons increases with light frequency. So first one, they assumed that it increases with light amplitude, but it increased with light frequency. With light frequency. Of electron increases with increase in light frequency, but remained constant with increase in light amplitude. And in second one, here they said rate of emission of electrons, that is nothing but electric current. Rate of emission of electrons means nothing but electric current. Electric current. Here they assumed that increase with light frequency, but it increased with light amplitude. Increases with increase in light amplitude, but remained constant with light frequency. See, the results observed are completely different from the assumptions. So there must be something additional with the wave nature of electromagnetic radiation to explain this phenomenon. At this stage, Einstein considered the particle nature of electromagnetic radiation. Albert Einstein considered Planck's quantum theory and then explained this first observation. According to Planck's quantum theory, E is equal to h nu. So, according to Planck's quantum theory, light have a particle nature and the smallest quantized energy is considered as quantum. And here Einstein considered each particle as photon. So, when the energy of the photon is considered, E photon is equal to h, Planck's constant, which is equal to 6.626 into 10 power minus 34 joules second. And here the mu is frequency of light. Mu is frequency of light. So here h is Planck's constant. When we remove the constant from the equation, E equal to h mu, if we remove the constant, then we add proportional. E photon is proportional to frequency. So if we consider the particle nature, the first observation, kinetic energy of electrons. Here the kinetic energy of photoelectron. Here the kinetic energy of photon is proportional to frequency. So kinetic energy of photon will get energy of photon will be transmitted to, see, energy of, here the light is there, photon is transferred to electrons. So kinetic energy of electrons is proportional to frequency of the light. So first observation can be explained through the Planck's quantum theory, which in turn suggests that electromagnetic radiations have particle nature. And then the second observation, electric current increases with light amplitude. See, here electric current is proportional to light amplitude. Electric current is nothing but number of electrons emitted. See, if the amplitude is more, then let us consider this one as photons. This one as photons. So here when the amplitude is more, number of photons will also be more. Amplitude is more, then number of photons will be more. If number of photons striking the metal surface increases, then the number of electrons will also be increased. Means the electric current will also be increased. So with increase in light amplitude, electric current will get increased. So the second observation can also be proved only when we consider the particle nature of electromagnetic radiations. So these are the observations. Again, further, when a photon hits the metal surface, the photon's energy is absorbed by the electron and then this energy is used to get out of the metal surface, and the remaining energy is used as a kinetic energy. So here when photon hits the metal surface, when the photon hits the metal surface, energy of photon is equal to the threshold frequency of metal and the electron's kinetic energy. So earlier we said that each metal will have a fixed frequency, certain frequency called threshold frequency, and this threshold frequency, the frequency of light incident on it, must be greater than the threshold frequency. Frequency of light must be greater than threshold frequency. So here the metal will have certain energy, means if we consider the atom, the electrons are held in its position. The energy transferred by photon is utilized to overcome the nuclear attraction, that is static energy of electrons must be increased so that the attraction force between these two is overcome, and then the electrons move out of the atom. Due to this movement, the static energy gets converted into kinetic energy. So energy absorbed by from the photon is utilized to overcome the nuclear attraction, that is threshold frequency of the metal, and then the kinetic energy. Therefore h mu, here the photon energy of photon is equal to h mu. So h mu is equal to threshold frequency, and the energy to overcome the nuclear attraction is there, no, that one, h mu naught plus kinetic energy half mv square. Here m is mass of electron, so kinetic energy of the electron. So energy absorbed by photon is utilized to overcome the internal nuclear attraction of the electron, and then these electrons moves out with some speed, with some kinetic energy half mev square. So this is all about photoelectric effect. Hope you understood this topic. If you have any doubts, comment in the comment box. If you understand this video, give me a like.